You've heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
Welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here. And we're going to have some fun today, folks. We're going to talk about some of the newest, coolest technology in data. We're going to talk about some of the oldest technology in the world of understanding and libraries, right? A library of insights. The future of data catalogs is the title of our show. We have three experts on the call today, including Brian Jacob, the CTO for Data.World, and a couple analysts, my buddy Evan Levy, who's been on the show before, a longtime expert in our industry, and Michael Baraz as well, a data governance and data catalog expert. We'll talk about what these things are, why you should care, and why you should be investing in them. And there are lots of fun things happening these days. The whole concept of a knowledge graph is becoming much more popular, and there's a lot of good reasons for that. A knowledge graph is, as the name might indicate, a graph that sort of represents knowledge or insights about particular topics. So a lot of times in businesses, we've talked about business glossaries, for example, which are literally just definitions of the terms we use in the business. There are some basic terms. What is a customer? What is a prospect, et cetera? What is a partner, for example? But there are much more technical terms too, and very important terminology for understanding your particular line of business. Well, if you think about any mid to large size organization that's been around for a few years has a ton of data. Probably 80% of that data is unstructured in nature. In other words, it's not in relational databases. It's in other systems. It's in file systems. It's in all sorts of forms, shapes, and sizes. How can you make sense of all that stuff? Well, the short answer is it's very difficult to do so. The longer answer is we're getting much closer these days, thanks to data catalogs, at being able to really catalog and understand and then share what all this stuff means. That becomes very important in organizations, especially when new hires come into the picture. A new hire, if you have a good data catalog, can very quickly find his or her way around and start getting stuff done for your organization. So that's what we're talking about today. And I'll bring in our first guest. Let's go right to Brian Jacob from Data.World. Very cool company you've got there, a very ambitious mission that you're on. Tell us the latest about what you're doing and why folks should investigate and use data catalogs.
Sure. Thanks so much. I think you mentioned knowledge graphs, and I think that's really kind of at the center of what we do and what we've kind of always been about. At the end of the day, what you really want is to understand what your data are about, what your data can tell you, to be able to, onboard new employees, answer questions in the language of the business. So the ultimate goal is really to build up a knowledge graph that has the understanding of what all of your data can tell you. But a step along that journey is really building out what you'd call a data catalog, which is what are all of the systems that contain that data? What are all the relational databases? What are all those long tail of other systems that you referenced? What data is in them? How's it structured? What does it mean? How does it relate to a logical model of what kinds of information exist in there? That's starting from the business glossary, which most organizations have some version of, up through more formal representations of things like taxonomies and ontologies. Ultimately, that's what we're doing, and that's kind of really what our core philosophy is that ultimately you're building out a knowledge graph that represents your organization's knowledge, and the way to get there is to really build that roadmap of what all of the systems are and build that knowledge graph first, so that on top of that you can build that. We're doing a lot of interesting work now with AI. I know everyone's kind of, you got all of the buzz around large language models and things like GPT and OpenAI out there. But the reality is, one of the reasons to build out this knowledge graph is because you have a structured representation of knowledge that can help communicate both with human beings asking questions in real world natural language and getting answers, and also with these large language models, and having a natural representation of the entities, relationships that make up your data estate is a really powerful way to integrate with these new AI technologies.
Yeah, you use the term data estate. I really like that term because it connotes the real estate side of the equation, right? I mean, with information landscapes, they really are very topographically challenging. There are peaks and valleys, there are rivers that go through it. There are streams these days, literally streams of data that come in. That's another whole concept in itself that is tangential to what we're talking about. But the whole purpose of the data catalog is to provide context and meaning for all these different terms within the business, such that anyone who wants to learn about something can hop on it. It's kind of like your Wikipedia, right? I mean, we've seen companies have wikis. They figured out, hey, this is an interesting way to share information. We've had portals forever and a day. Remember the intranet concept early in the days of the interwebs. You've got your network that you connect to. But the key is to really have this rich contextual, let's call it semantic layer that helps to define and gives the employees and even the partners the capacity to learn and also add back, right into the environment to further explain things, right, Brian?
Absolutely. I think, it's a really good analogy, but I take it one step further because I think it is like a Wikipedia. It needs to be read right. It needs to be an interactive process, and it needs to serve humans as a readable bit of context around what this data is and how it relates. But it also needs to serve machines. It also needs to be machine readable. And so, I mean, I would take the analogy. I don't know how many folks listening to this are familiar with Wikidata. But Wikidata is another project coming out of the same group that puts together Wikipedia. But what Wikidata is literally a machine readable structured knowledge graph of the information that can be extracted from all of the natural language that sits in Wikipedia. And that is an incredibly valuable resource. And it's built on all of the kind of standard knowledge graph standards, RDF, Sparkle, the semantic web kind of graph standard database tools, which is the same thing we've built our technology on. And I think it's important to kind of, cross the chasm between those two things. It can't just be a wiki that has words for humans to read and consume. That's an important part of it, and that gets people into the loop because people are an integral part of this knowledge management. But it has to, that same information has to be machine readable in order to really, automate things like governance and access and insight generation.
Yeah, it's a really good point. Machine readable is key to make this thing functional so you can plug it into different systems. And, it's always fun for me to appreciate how these different technology spaces can kind of overlap each other. And you just made a reference to something. When it's machine readable, you can automate certain aspects of governance. So think about DLP, for example, data loss protection. Well, companies use that to prevent employees from emailing credit card numbers, for example. But with your technology and with semantics, for example, and some automation, you could see when someone is posting something about a particular topic. If it's a very sensitive topic, you can at least automatically flag that such that someone else will read it and make sure that it's okay. So it's a way of embedding these sort of dynamic triggers to help the business stay on top of who's talking about what and who's doing what, right?
Yeah, absolutely. And again, having that connected network of how everything hangs together. So knowing that something is potentially sensitive or otherwise risky piece of data is important. Knowing what flows downstream from that, thinking about like the data lineage, the provenance of how information moves from system to system, lets me then take that information and say, not only do I know where this point of impact of having collected some potentially sensitive data has occurred, but what else downstream of that, possibly through many hops, has been impacted. Or I can reverse that problem and start from, I'm observing a problem somewhere in the field. Like this data is wrong, this outcome isn't occurring. What might be the root cause? So just having a lot of what we inherently live in a federated world, right? Any reasonably sized organization is going to have a pretty, use that data state world where it's going to be broad. You're going to have the modern data stack systems that you rolled out in the last few years, but you also have the systems that have been operating in the business for sometimes decades. Those things don't go away overnight, no matter how much you want to modernize. Being able to go out independently to speak to all those systems, extract their metadata, have a strong notion of identity of what each of those things really are and how they're connected, and be able to represent that in a connected graph is really, that's the problem that everyone's facing is that you have to be able to kind of in a federated way go out and talk to all these systems, synthesize that data, bring it back together, it is fundamentally a graph problem, right? I think that's the thing that, like, a lot of people ask me, like, well, why does your system have to be built on top of a knowledge graph or a graph database? Couldn't I just build this on a relational database? And you could build anything on anything, right? It's software, but the reality is it doesn't, it's not really kind of respecting the true nature of the problem. Like, this is fundamentally a graph problem about entities and broad relationships and how they hang together. And by building it on a technology that supports that, natively as like the first class paradigm, you just get a lot more power and flexibility. And I think knowledge graphs are really kind of having a little bit of their day, and the people are talking about it a lot more. I think what's happened is, the really large, really complex organizations, every bank, every pharma tech company, Palantir, Google, those kind of companies, they all hit the level of data integration complexity that required a graph-like solution to the problem 15 years ago. They all have this technology kind of built deeply within there's but there is a learning curve to it, right? There's a paradigm shift, there's a cost to switching to this. And what's happening now is, I think every organization is hitting that point of just complexity where nothing else really works for data management at scale, and people are starting to realize that. And so I'm happy to see, because I think it's just going to increase the level of investment and attention on solving this problem.
Yeah, that's a good point. And so, to explain to our audience, a graph database. So we're talking about knowledge graph. It's a graph database. Graph databases are much different from relational databases or the usual sort of Microsoft Excel rows and columns that you see. Graph databases use nodes and edges, and a node is usually an object, a thing, like a person, for example. An edge is a characteristic of a thing or a person, and you can have as many nodes and edges as you want. And of course, they can all relate to each other. That's why it is very useful for discovery and for understanding relationships between different entities and even different systems. So it's a very, very powerful technology to underpin a system like what we're talking about today. And let's get some commentary about that from Michael Baraz, who has built several data governance programs for major organizations and has been in the weeds, in the thick of it. And we were joking before the show that you need vision and endurance, right? It's more important than truth, endurance. What do you think, Michael?
Absolutely. Well, and there was just a mention of the importance of automation and being able to do things at scale. And that's really the big differentiator. I had been using data governance tools like data catalogs for years, but until the automation began to really become prominent and accessible to the tools, it was really an uphill climb. And to be honest with you, as much as I love doing it, it was not particularly that easily to justify the cost of what we did. So really, until we had the automated tools, and for my own learning curve, it was somewhere around 2016, 2017 when I first started seeing these tools coming about with the machine learning, with the AI, with the automation, things that we could do at scale. So in other words, trying to do one table or one database at a time instead of like turning it loose and letting it come back and then connecting the dots for us. That was really, the step function of now we're in the promised land, or at least we're on the road.
I like that. I like the step function too. It's a chemistry term, right? It means it's not just one incremental change. It's a very significant change. It's a step change, as they call it. So things get significantly better. And you made an excellent point there, and so did Brian a moment ago, that the capacity to reach out dynamically throughout the information environment, typically through the network, and see all the different sources and targets and dynamically pull from that, especially the metadata, that's really, really important for being able to understand what is the big picture. Where is this information coming from? Where is it going? We're really at a very promising and exciting stage in that particular dynamic. What do you think, Michael?
Yes, and the sustainability is really key there too, because when you've got these automated processes, now you can find schema drift that you didn't know about, right? So as things are beginning to change and you're not aware of those changes, they didn't go through the change management process that they're supposed to go through. Right. All of a sudden, we find things that are changing before they break our pipelines and other really critical business things, where now we've got real big work to do in the middle of the night. So catching these things early and keeping them up to date and keeping the documentation in sync with the reality is like as good as it gets.
Yeah, that's a really good point too. So knowing when data pipelines break, for example, or knowing when something is just askance, if you will, knowing that something you mentioned schema drift. Can you describe for our audience what that means in
We used to
business
have
terms?
we used to have 4 columns. We had customer, we had phone number, we had email address and address, right? And all of a sudden they tack on credit limit. Now we have a fifth element or fifth attribute we didn't have in our previous feeds. And now what do we do with it? Or worse, they're in a particular sequence that matters, right? The first column has to be customer number, and then the second has to be name, and then someone sticks something in between, and that name now becomes a number because it's in the second sequence, right? So schema drift is anytime the structure of data changes, and ideally we know about it. But if it's just one of those things that a developer does because it was convenient. Good for them, not so good for us.
Yeah, well, that is a real concern, right? And with the whole DevOps movement, we finally had developers working directly with operations people, which I think did wonders for getting things done and for actual digital transformation. I also think it helped kind of dull the divide between business and IT, which in some cases was an acrimony. And I think it helped to get a third person at the table now. Not that the developers are necessarily good liaisons, just because there was someone else at the table who could explain exactly what has to be done in the inner workings of the systems to make it work on your iPhone, on your iPad, on a web browser, whatever the case may be. I mean, that was all good stuff. And, the other really positive side of these knowledge graphs and of data catalogs, again, is that they help the business understand who's doing what, when, where, why, and so forth. And so, typically when people know why something is happening, they're much more amenable to working with you on something. But if there's no why, if there's no explanation, then well, what do you mean? Leave me alone. I already got my job to do. So I think they do help grease the tracks of transformation, of getting things done. Right, Michael?
Yeah. And, even simple little things like a column that's been designated as 16 characters. Now we're merging systems and something comes in with 20 characters in that column, goes off the rails. And then, we don't have any visibility over that without something that's an automated learning process that runs autonomously.
Yeah, and there are very real costs to these changes. I mean, just in the world of mailing things, and yes, there are still letters coming in the post. I get letters all the time. And just in terms of mailing out proposals, mailing out brochures, mailing out invoices, bills, whatever the case may be, those kinds of changes can throw things off significantly where people don't get their invoices, people don't get their money, people don't get their products. Those are the kinds of things that cause real harm to the business. And that's why you want to focus on understanding your data, knowing where it's supposed to live, knowing what it's supposed to look like. And like Michael said, when you automate these processes, then you can sense schema drift, or you can sense some change somewhere that's going to affect somebody, and then even do an impact analysis. How about that idea?
I was just going to, you beat me to the punch. So
we'll be right back, folks. So you're listening to DM Radio. Stand by.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
Back here on DM Radio, talking about the future of data catalogs. Yes, a library of insights. Yes, that's what they are. They are a library of insights. They also help you understand the meaning of business terms and your organization specific terms, and a little bit on the process side too, which is kind of interesting. But next up, we have Evan Levy, a longtime friend of mine in the industry, and a real source of information and insights just all by himself. And Evan, you were making some interesting comments there in the break about something that we had not yet touched on. So go ahead with that first.
Yeah, I think what's so interesting about what Michael and Brian are hitting on is, well, I think there's actually a couple of pieces. One is the whole awareness of what is the user, the analyst, really trying to take a look at, and how their tasks and activities and approaches evolved. 15 years ago, it was they ran the same reports, and maybe they did drill down or drill across, but they use the same 3 or 4 or 5 sources. Well, what we now have in most of our business environments is a multitude of incremental data, a multitude of breadth, not just depth. So we've got more sources, and users are smart. I mean, they've been working with this stuff. So the whole idea of the value of the catalog now tells me, what other customer data do I have? and I can actually add on more content and more sources to the analysis that I'm doing. So one of the core values of the catalog itself is not just what content did I have yesterday, but what content now exists today, tomorrow, or next month as other data providers, whether those be users or syndicated data sources, add to it, so someone can continually look at, hey, I can add this and do something better. It's like the chef or the cook that goes to the grocery store and realizes, hey, look at these new ingredients I now have access to because they have produce or vegetables that they didn't have a week ago. So they can improve the quality, the cost, the flavor of something. The same thing goes for what an analyst can do because of the catalog.
Mm-hmm. Yeah, and you made a good point in the break there a moment ago about the difference between an operational database and an analytical database, and that the analytical environment, you want to capture everything and be able to analyze and understand. The operational system has to do stuff. I mean, if you look back at the history of data warehousing, we built data warehouses when we realized that we couldn't query transactional systems. It just didn't work very well. They weren't designed to do that. So we pulled all that data out, we ETL'd it into a warehouse. Of course, that's sort of changing these days as well. But point being, there are these different technologies that have different uses to them. And some analytics environment, you want to be able to capture everything to see what's happening, see what's going wrong. Is that right?
Yeah, it's think about the dimensionality. I don't mean in a relational perspective, but the dimensionality of information. If I'm just looking at a bank's deposit system and you say, well, how much money was deposited across all our branches or a particular branch or whatever, it will tell you, here's how much money was deposited. But now when I want to go down the path of things like, well, but how many deposits were placed on inaccurate account numbers, or in fact, accounts that haven't yet been opened? For those of you that want to know some little esoteric things, it's not uncommon in a bank that when you create an account and you do the deposit, because of the way the systems work, the deposit actually leads the account. Or unfortunately, sometimes someone's goofed and didn't open the account. So you've got these deposits with no place to reside. The value of what a data warehouse provided in the early days was show me all those business anomalies. Show me where there isn't the integrity, where children don't have parents, or account or transactions don't have accounts. So I want that. And now with the value of having the data catalog have the information of what is there, I can take a look and actually analyze what are all these business anomalies that maybe I lost track of. Here's all the orders that were placed. Here's where all the orders that were fulfilled. Well, were all those fulfilled orders paid for? And as funny as that sounds, this is where, as both Brian and Michael were talking, the value of analyzing the process. Now what I can do when I've got the catalog and obviously having the data across these different systems, I can actually track things like workflow. I can track business process, and more importantly, find those anomalies. You were talking about tracking the relationships. Let me track the transactional details as it crosses systems. And I can analyze that, which wasn't even feasible 15 years ago.
Oh, it's amazing stuff. So I was referring to process mining in one of our breaks here, and there are several companies doing process mining these days in different ways. Typically, they look to the log files of ERP systems and they track all the log files. And they go, okay, here's what actually happened. I mean, to most business users, it might sound odd, but the fact is, especially in larger organizations that have ERP systems or even multiple ERP systems, when you hit that button, you think you know what's happening, but do you? You may not. It may be going to other systems, pulling in data, calculating scores, for example, and really understand that end-to-end process is really valuable because number one, then you can optimize things. And number two, you can also redesign things, right, Evan?
The whole idea that you hit on is I've got these business processes in place, but what I really have above that is a data supply chain. Someone has generated an order, they placed it, things got pulled out of inventory, a payment occurred, something was fulfilled, something was shipped. And in the size of our companies in this day and age, that may actually cross multiple vendors and suppliers to be able to help. The person that's fulfilling or the entity that's fulfilling an order isn't necessarily the entity that's actually handling the shipment or delivery and so forth. So I think as Brian mentioned, the whole idea of we have to live in an age of having disparate federated data, which means the processes themselves touch those disparate federated systems. So how do we keep track of it all? And that's, I think, one of the powers of what the catalog brings to the table is let me actually track the data as it moves through the process. And is it there? Did I drop or forget something? And allows people to ask the questions that they inevitably want to ask, which is, Are we losing money? Are we making money? Or where is the slippage? And they can now go trace the processes themselves and the associated data to find out, did I drop an order or did I lose something? I mean,
Right.
how many folks have call somebody because you've got a customer support need, and I won't even get into the challenges I have with my cable company. You hang up, a day later you call them back and they don't yet have the details. Case in point. And they say, well, who'd you call? It's like, I called you guys. Well, they have 40 different call centers and they have three other outbound groups. So this is the real life challenge that I think we run into, where a catalog would make a difference.
That's very interesting. And, to kind of explain to our audience here, most people know what a database is. You understand there's a customer database. You understand there's a product database. These come together when an order is placed. I pull the customer information, grab their credit card, ship the product out. But what we get with a data catalog is really sort of a lattice that goes over and into all these environments to get us better understanding about this system, that system, what kind of data you can get from here, what kind of data you can get from there. And so it's a very powerful resource for, again, educating the business, individual business people, and the business writ large as well, about what's where, who to contact. Certainly you can have that kind of information in as well. Who owns this system? Who owns that database? Who's responsible for this stuff? You need that for accountability. You need that for audit trail, right, Evan?
Yeah. If I was to take a look at what I perceive to be powerful, it's we all have our top 3 or our top 5. I tend to deal with more of the business user versus the technologist, and a catalog, case in point, does what are the terms and what do they mean. But then you get into things like linkage and lineage. Where did it come from? Where is it going to? So now when I have that, if something breaks, I want to know, well, how will it affect the downstream folks? If a bank, for example, didn't take my deposit correctly and I'm starting to write checks, obviously that money doesn't exist because it's screwed up on the deposit. The same thing goes for the types of systems and circumstances we're talking about. The idea of this knowledge graph concept, I think, is very, very powerful, because it lets me understand where did the data go and what other processes are using it. And that's possible because the catalog has its connections, not just what it means, but where did the data come from? What are the load or conversion activities? In fact, what are the rules about loading and converting? We take certain things in our business world for granted. There's technologies we're not allowed to ship to certain countries. There's other types of data we're not allowed to ship to other countries. The catalog would actually, in this very simplistic example, would help us understand those rules, because these are not uniform rules. These are data value centric rules. So it's not like everything here can't go there. I've got to actually interrogate the underlying details. And if that was a manual process, what's the likelihood of errors? It can't be. It's got to be automated.
Right.
So everything that Michael and Brian were hitting on, obviously I get excited about this stuff because it's now feasible to track the rules themselves.
That's right. That's right. And
it's not just track them, but promulgate that. Publish it so everyone else can know about those rules. Oh my God, the amount of stuff in the gray matter that runs out the door when someone retires or goes off on vacation. That is just tantamount to disaster.
Yeah, that's an excellent point. Let's bring in Brian to kind of comment on this stuff, because the lineage is really important. And ever use the great term, the data supply chain, right? There's data that's coming in through various systems, and then it gets joined with data that's already in your systems. Of course, authentication, verification, things like this. But being able to understand that whole process is extremely valuable, again, when you're trying to improve something. Like, let's say COVID hits and you're trying to change your business almost overnight. That kind of thing is extremely powerful, because now the engineers can get in and they know where to point stuff. They know where to get stuff. They know where to put stuff. Whereas if you don't know where to put stuff, you usually come up with a new bucket to put it in, right?
Yeah, for sure. I mean, that's a big part of this, is like just kind of, eliminating some of that shadow data ops or shadow IT, where folks say like, well, I didn't find what I needed, so I just went and completely recreated it myself. And now there's one more silo,
which happens all the time.
Which happens all the time. But yeah, I mean, as you alluded to there, there's a lot of systems involved. It's inherently federated. So you can go talk to the individual databases and the data systems with their APIs and find out what they represent and what kind of information is in there and what their schemas and structures are. But you have to also go out and talk to and automate connections with ETL systems that are moving data from point A to point B, and other kinds of data transformation layers. that federated notion is, it's sneakily complex, because you got to be able to go talk to all these various systems. You've got to agree on a common way of knowing that, like, this database is named the same thing everywhere I refer to it, and when I stitch together these connections, that I'm always referring to the same thing. And these are all things that change over time, and they drift. But I think the distinction we drew between operational and analytical systems is really important, and like that analogy, even across the data catalog, is really, you need to be able to represent the world as it is. You need to be able to have an accurate, faithful description. If I went out and talked to all these systems, this is truth that I have harvested. And you want to be able to represent the world as you want it to be, or as you need it to be, or as it can be used in a compliant manner, where you're modeling your policies, you're modeling, as a real world, just as like, kind of a quick high level example of some of the stuff that Evan was speaking to. I want to be able to go ask a question. Can I use this data from here, and get an answer, yes, no? And that automation is really, how do I automate the 12 or 50 questions that have to actually be answered of, well, what physical jurisdiction is this data residing in? And what are the regulations and rules and internal policies that govern its use? And what am I using it for? Because it's not ever just as simple as, can data from this geographical jurisdiction be used in this other one? It's, what's the context? What are you doing with it? Are you using it to fulfill a business business process on that user's behalf? Yes, you can use it. Are you using it to market to them? No, you may not. And all of those things are policy, and it's, so it's not just about being able to discover these things, but you can actually automate the governance of these things to a degree, to say, I really just want the answer of, can I use this data that I have found that seems to be fit for purpose for this purpose, and be able to reason about all the various pieces of that all the way down the chain.
Yeah, and you want that decoupled from the data, right? So to Michael's point a moment ago, you want to be able to promulgate these policies dynamically. So let's say country XYZ changes their rules on something, or even in California, the California Consumer Protection Act, I think it's called, CCPA. Yeah. They come out with all sorts of regulations. The more you have refined your layer of abstraction around policy, the better off you're going to be, because then you'll be able to easily say, okay, this rule change, that rule change, boom, promulgate it, and now we're set. Whereas if you didn't have that layer of abstraction, you're in big trouble, right, Michael?
Yeah, and that goes to, back to the idea of the machine learning and the automation stuff. If you've got to do that manually to create those semantic relationships between things that are conceptually the same, you're never going to get the job done, and you're always going to be chasing your tail. So the question is, like, how can you leverage tools to go about doing that? So you've got to have that ontology, that concept of, I've got these things and they're related in this way. And now those things are instantiated in these 42 different places, right? But some are related, one for, in semantically the exact same, and some are just kind of related terms, and you have to be able to distinguish between those as well. Mm-hmm. So you got a limit, in insurance terms, you got limits and, and sublimits on policy stuff. You've got to be able to differentiate between the 42 different types of limits, because when someone says limit, which one do you mean? Mm-hmm. So now we have to be specific and clear.
Yeah, no, that's a really good point. And it kind of gets back to some of the other topics we're talking about. You need to be able to see the world as it is, as Brian was talking about, but you also want to be able to understand the impact of what you change. And so a data catalog can really help you get that strategic view of what's going on, and then be able to make a reasoned, informed decision. Okay, we're going to merge these two units together because we think it's going to save us money in X, Y, and Z, in hard costs and various other costs. I mean, these are the kind of decisions that executives have to make, especially when times get tough, right? Anyone can be a good leader when the money's just rolling, but as soon as someone pulls the string, that's when the real leaders step up to the plate and figure out how to do stuff. And they need the information to be able to make those decisions. That's one thing these data catalogs can provide you, is the context and the meaning. We'll be right back. Don't touch that dial. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, talking to several great experts all about data catalogs, a library of insights. We've got Brian Jacob from Data.World, and a couple analysts on the call, Evan Levy and Michael Baraz. And speaking of data and understanding data, cardinality. We talked about that earlier in the day. Just define for our audience, for the lay business person, Evan, I'll throw it over to you. What is cardinality in database technology, and why does that matter?
Well, really, when you're loading data and you're having to retrieve it, what the underlying system needs to understand is what's the diversity of values. How many are unique? Are there lots of duplicates? And to the non-technologist, you wouldn't normally care about that. But if you think about the way we track business information, we shouldn't have duplicate account numbers. We shouldn't have duplicate transaction IDs. And what's important when you're trying to merge data across different systems is what is the diversity of values? Are there uniqueness or not? And just keeping track of that so that the answer you're looking for is always an accurate answer. So the reason for cardinality, that type of stuff is needed by the brains inside AI, the brains inside databases to know how to merge and manipulate the data accurately.
Yeah, and I'm glad you brought up AI, and let me throw this over to Brian to tackle, because it's a big deal. Lots of companies are now looking into AI and large language models, for example, like ChatGPT. There are others. Databricks came out their own Dolly, which looks pretty interesting too. The key with using AI is that you have to be very careful about where you point it, about what access you give it to your data, because all AI must be trained on models. I guess there's adversarial AI that can kind of train each other, but by and large, you train an algorithm on data, and you do it for a very particular purpose. It's usually for segmentation or to optimize a decision point in a particular context. But the key is you're using data to be able to do that. And if you just open the kimono and point at AI at all the data you have, and you don't know what data you have, you're going to have some very interesting, bizarre realities in your world, and you're probably going to wind up being a very unhappy person. But Brian, you want to take that and kind of talk about why it's important to first catalog your data before you start pointing these incredibly powerful algorithms at it?
Sure. Yeah, I think, as there's a couple different dimensions of the AI conversation you're on right now. But if you're talking about training models on your data, I mean, it is really important to kind of do the feature engineering, the understanding of like what is this data, what does it actually represent? The pitfalls you can fall into are, there could be all kinds of bias embedded in data, and that can be kind of that can take a lot of different forms. That can be that can range from kind of just really societal bias embedded in the way data is collected to just incorrect conclusions based on the way that the data has been harvested and collected. I mean, ultimately, neural networks are incredibly powerful. All the kind of machine learning technologies are incredibly powerful, but what they are is they're statistical prediction machines. They are basically saying, I have looked at a lot of data, and based on all the data that I've looked at, I can take a partial piece of data and predict what the rest of it looks like. And if you kind of look to traditional machine learning and how it's applied for things like data classification and things that we do a lot with folks in our data catalog, that it's powerful, but it's only as good as the data you feed into it, right? And you kind of have the division between supervised and unsupervised, and you talked about like the adversarial networks, which can get into some reinforcement learning. All these techniques are really powerful, but ultimately it's only as good as what examples it has to learn from. It can learn wrong things from looking at looking at wrong data or data that's presented in the wrong way. When you look at these like large language models, I mean, they're massive and they're impressive and they can do some really powerful things, but they're fundamentally the same thing. I mean, ultimately, we attribute all kinds of things like reasoning to what these large language models are doing, but it's not really what they're doing. They're predicting the completion of a bit of text, right? You're saying some words and it's saying, when I see words like that, the words that, based on having read millions and millions of documents, the words that would be the most statistically likely response to that are these. That's powerful, but it's an incomplete story. And like when we start thinking about using these things in data, within your data estate, within your data, in your data governance, there's a real problem with thinking that these are hammers that can hit every nail. You would not want to answer fundamental questions that are fact-based by training a large language model on a bunch of data and asking it to give you the answer, because you're going to lose all of the provenance of where that answer came from. You're going to lose all the ability to kind of trace back how that you can and should use these technologies. They're powerful. The right way to do it, and I think this is where data catalogs become so important, is you want to train that model on your metadata. You want to teach it how to think about your data structurally, and you want to teach it that when you have fact-based questions that you want to answer, you can ask a large language model, turn this natural language question into a query, and then go execute that query against a structured, governed, known database, a knowledge graph that can actually be governed and understood to get back the answer. You still want the same net effect. You want an executive to be able to say, what were our net sales last quarter, and get back an answer and move on quickly. But you also want to be able to say, what database did you go consult? What's the query you ran? Does that track with our governed metric that we report to the SEC on how we calculate that? So I can actually say that answer is correct according to our governed policy, so I don't have to go to jail. So you want both. You want the quick, easy answer, but you definitely don't want just an opaque answer that's statistically probably pretty close to correct, having read all the data.
That's very interesting. That's a very interesting point, and I'm reminded that AI, you could view it as like a child, right? It will learn things, and so it can learn the wrong things. If you don't pay attention to what your child is learning, your child may learn the wrong things and then go around saying things that are wrong. And if it's a silly thing, it's okay, but if it's a very important life lesson, then it's not okay. So you have to stay on top of these things. And I see both Evan and Michael shaking their heads yes. And Evan, I'll throw it to you first. I think the key with AI is that it's going to be great at making recommendations and giving you things to think about, but you still have to determine yourself. And there is this whole dynamic of stochastic versus deterministic, right? Your data warehouse should be your deterministic environment where, as Brian said, yes, we report this to the SEC. Your stochastic environment can be much more open because it's all about discovery and just learning new things. But what do you think, Evan?
Well, I think there's one thing that I think the group of us are taking for granted that let me just hash through was the whole concept of training. We've talked about it where we want the system to learn about certain types of data so it can now tell us things we don't know. The idea of training is to give it a long list or lots of detail. If you do it wrong and you train it on the wrong elements, it will tell you an answer that may be accurate but unusable. My favorite story was there was a consulting firm years ago where they studied attributes of staff members to understand, well, who's the most likely person to work for us? And the system came back and said, whoever wears a white shirt, because they actually studied and identified what everybody wore, and all the males wore white shirts because, oh, by the way, there was an unwritten rule in the company that you got to wear a white shirt. Now that's 100% accurate and completely unusable. And I think the reason I use that example is what we really want to understand and have these systems learn are the things we don't fully understand. So training on certain attributes or data details that, as we just talked about, we want to find out, is it a byproduct of what happened, or does it cause the event to occur that we're expecting? So there has to be some level of guided learning. And when we talk about training, that's what we're really focused on, is how do I give the system enough information, enough data detail that it can learn and then apply what it learns to more data to figure out if the logic that it's creating is accurate or not. And oh, by the way, is also usable. So again, pardon me for hacking through what's obvious to many listeners, but one of the big challenges with AI, and what you may have heard about with the Microsoft versus Google, and where Google kind of goofed, was it trained things, and while the value may have been technically accurate, the information was not usable or in context for what they expected. So you got to work through this, because let's go back to what we were talking about with the catalog. I've now introduced a new data source, but if that data source has never been used and we can't determine if the data that this source has is even accurate or timely, now I'm training a system to make decisions on inaccurate information. So that thus the value of the catalog being able to characterize and track, or characterize, is this known acceptable information or completely unknown unused information? I mean, we take for granted when we go to the grocery store that whatever we eat's not going to kill us. We assume that it's been tested. We've assumed that others have certain types of test and inspection. Well, the same thing goes if the data has never been tested or inspected. We have to proceed cautiously if we're allowing these systems to go learn about it. So it's not about buyer beware. It's about let's have the right expertise that's driving these systems to learn these things. So pardon me for going off a little rails a little bit,
No,
but I wanted to
that's
touch on
good.
that.
Yeah, and you actually were singing the tune that Michael Baraz loves too. When you talk about looking at the product label at the store, you presume that this stuff is safe because it's there, because someone has curated it, someone has governed it already. And that quote was classic. That's 100% accurate and completely unusable. We don't want things that are accurate and unusable for sure. Well, folks, podcast bonus segment is coming up next. You are listening to DM Radio.